that worked at the university in the student health services. These machines were donated to the university. They were used in the student health. This doctor actually used this. These currents were diathermy, so they did it for heating, physical effects, surgery, and when they became out of favor, and this machine, folks, was built in 1927. This is not a turn of the century, this is 1927. The only reason they obsoleted this machine was because it wasn't controlled on frequency. It's a broadband generator. So as they started going to the shortwave diathermy, which was the next step, they were still a free-running oscillator, but they were kind of 12 megahertz or 27 megahertz. Then after the war, they said we've got to be crystal controlled because everybody started using radio. Before that, everybody just used AM radio mainly. But this was used in the medical profession. It came from Bozeman, Montana. Who bought the machine originally? I don't know. I do not know who bought it.
Do any modern hospitals use descendants of that machine?
Modern hospitals today, yes. There's actually two descendants that they still use. There's still shortwave diathermy used today. A lot of people use ultrasound for heating tissues, but shortwave diathermy is still used in a lot of physical therapy. The other machine that's used, anybody here got a back problem besides me? Anybody use a TENS machine? TENS, transneural stimulation? Well, a TENS machine is a modern version, size of a cigarette pack, is what they call a Faraday coil. It's just a DC pulse that stimulates the nerve to the point where the nerve shuts down. It uses its chemicals up to send pain, so it's a pain blocker. 100 to 150 years ago, they were called Faraday batteries. They were an induction coil modified, wonderful to shock you with and have fun with the neighbors. They thought they cured diseases because the symptoms went away. Symptoms went away because it blocked the pain. That, 150 years ago, I have some coils that were built during the Civil War, 1860s. Nowadays, they use the same type of energy. They realize it's a pain blocker. It doesn't cure, but it's a pain blocker. Diathermy is still the only way to get deep intramuscular heat. Ultrasound will not penetrate. It's still sound waves. It diminishes as it goes in. Diathermy still works, and they use a modern form of diathermy. The frequencies are different. This is around 100 kilohertz. The diathermies today are 27 megahertz. And they also use microwave diathermies. I have a microtherm where they actually have a microwave antenna, and they run at 2 gigahertz. It's a freestanding microwave oven.
Yeah. Okay, I have one last comment that, probably not even 1 out of 1 million people on this earth are aware of this type of technology and that it existed then. And what I've seen here, I never imagined it existed myself, and it's such a great tribute to Tesla, and it's a tribute to you guys who have dug this stuff out and preserved it for posterity. It's unimaginable almost, and I think you guys have done such a wonderful job preserving and presenting this stuff.
Thank you. Let's fire up the Hogan. Yeah.
All right, the best for last. And also, after the lecture's over, you're welcome to come down. I can open the cabinet up here, and you can see how this machine is plumbed. I say plumbed because there's 1/4-inch copper tubing as a wiring in here. Which mode do you want to go first?
What voltage is being applied here?
On which part? 110 volt in.
Let's start with a Whedon. Why not?
Okay.
It's a low power.
Yeah, it's at low power. Okay, Whedon coil first. This is a low frequency coil. That's low frequency, low output.
Low power.
Low
Theoretically. Whoop.
Notice when I'm drawing the energy, he's losing the energy.
Frank, can you keep your microphone away from the coil? Or while you're working, just turn away from it so we still want to hear you.
You notice now,
Show the Tesla.
the second output, totally different frequency. I haven't got a clue what this frequency is Tesla. This is this 6-turn coil.
This is pure resonance.
It's this ball right here. And we'll start out.
Okay, ladies and gentlemen, I know we're starting to run tight on time. The presenters have about 2 more minutes. However, there is an evening social, and those that want to remain for a few minutes, as long as the presenters choose to, we'll allow them to go ahead and continue to do displays. There's one rule, the 36-inch rule. You cannot come within 36 inches without their hand being involved with you and their hand giving you permission, okay? But otherwise, as Frank and Jeff see fit, we'll continue the experiments and the demonstration. This display will be removed this evening, so if you'd like to examine any of Jeff's or Frank's displays closer, now's the time. For those of you who wanted to or had to go to other appointments or go to the evening social, you're free to, you're done in about a minute, but we'll keep on with the experiments.
You can hear a spark gap running. You don't see anything. What do these controls do?
What are those controls?
Okay, this is just strictly basic an auto transformer to control the input voltage to increase power. This machine has a series of spark gaps. This is a spark gap regulator, just like I say, it's basically a Tesla coil. Yes, it does. It actually has a multiple set of plates. There's a group of stationary plates and a group of movable, and all the movable plates run in parallel against the stationary plates. Yeah, it's a multiple spark gap. You can...
The 10 series gap, I think. As far as multiple primaries, no taps?
Or multiple secondaries. Yeah, in other words, a secondary and then a third area and a fourth area.
Well, actually, this coil here is tapped at different points,
Yeah.
just to get lower voltages.
Okay, now you're seeing in a flue here. That's 1-to-1. Now what? The diathermy coil. There's a tap right here at, okay, the primary comes in basically at 0 to 3 turns. At 4.5, there's another tap. So this is That's resonance, 1 turn. residents versus non-residents on a one-to-one ratio. This is what's neat about this, is it shows two different types of coils. Like I say, a very simple pancake and a Whedon, but not a lot of turns. Everybody thinks Tesla coils have to be miles long and miles wide and high voltage. They don't. Resonance.
So is there a capacitor in here?
Yes, there's an oil-filled capacitor. There's a capacitor in the series with each side of the oscillator circuit. If you guys want to come up afterwards, there's actually the original schematic still.